Dear students, good morning. Welcome to online class. I am Mrs. Kala. Today we are going to talking about measurement. Before starting our class, I would like to start with a lovely quotation. One accurate measurement is worth 1,000 expert opinions. I think this quotation summarizes the importance and need of the measurement. Without the accurate measurement, we could not able to use the approximate values. Now let's go begin with our class. See the first figure, it's given clock, isn't it? What is the use of clock? It is used to measure the time. So we can measuring the time. So the time shows 10:10, isn't it? And second one, see the figure, measuring tape. It is used to measure the length of an object. We are measuring length. And see the third figure, it's given beam balance. Already you know what is the use of the beam balance, isn't it? It is used to measure the mass of an object. We have to say the weight of an object. So, using these figures, what we are trying to measure? We are trying to measure its physical quantity only. So, the next question will come is needed. What is physical quantity? So, the physical quantities, the quantities in terms of which laws of physics can be expressed and which can be measured directly or indirectly. And this is only is called as physical quantity. So all the quantities can be expressed with the help of laws of physics only, and it may be measured directly or indirectly. For example, we have to consider as a length of an object. A length is equal to 5 meter. So in this example, 5 is taken as a magnitude and a meter is taken as a unit only, 5 meter. And mass, let us consider as a mass 20 kilogram. So 20 is taken as a magnitude and kilogram is taken as a unit. So using these two examples, we could able to say physical quantities have magnitude and unit. Physical quantities have what? Magnitude and unit. So in our daily life, we are using the different units, isn't it? Some of the common systems already studied in our lower classes. One is taken as a CGS unit and another one is taken as a MKS unit. We are following the SI unit also. Okay. So the physical quantities are classified into two types. One is taken as a fundamental quantities and another one is the derived quantities. So what are the types of physical quantities? One is fundamental quantities and another one is derived quantities. So what is fundamental quantity? So the fundamental quantity is nothing but the physical quantities which do not depend on any other physical quantities for their measurements. Already you know the meaning of the measurement, isn't it? It is used to measure something. Whether it is used to measure the length of an object or mass of an object or the area or the volume of an object, like that. Already you know that word also, and also you study in our lower classes also. So the physical quantities which does not depends upon any other physical quantities for their measurement is known as fundamental quantities. Examples: mass, length, time, temperature. So the second one is the derived quantities. So the derived means it could able to derive from the physical quantities only. Either it is multiplied or it's divided. So the derived quantities can be expressed in terms of fundamental quantities. Examples: speed, volume, density, etc. Already you know the speed, volume, density and all study in the 7th standard. It's needed. So the speed is nothing but distance by time. So the distance is nothing but we could able to measure the length. So the length is taken as a fundamental quantity and time is also is taken as a fundamental quantity only. So these two fundamental quantities are used to derive one more quantity that is taken as a speed. So the speed is undercomes in the derived quantities. And volume. So what is volume formula? That is length into breadth into height. Yes, so length, breadth, height, that and all we are measuring the length. It undercomes the fundamental quantities only. And density. You know the formula mass per volume. So mass is taken as a fundamental quantity. So mass per volume, it gives us another quantity that is taken as a density. So students, I hope you understand what and all we discussed here is needed. So the first we discuss what are physical quantities and what are the types of physical quantities and what are the definitions of the fundamental and the derived quantities. And now let us move on to the fundamental quantities. We have 7 fundamental quantities: length, time, mass, electric current, temperature, amount of substance, and luminous intensity. These 7 quantities are called as fundamental quantities. Now let us move on to what are the corresponding units of the fundamental quantities. Length. The unit is meter. The abbreviation is small m. Or we are using the symbol is smallest m. And second physical quantity, the fundamental quantity is time. Unit is second. It is denoted by the symbol small s. A third quantity is mass. Unit is kilogram. It is denoted by the symbol kg, small kg. So these 3 fundamental quantities already studied in our lower classes 6th and 7th. So the remaining 4 quantities only we are going to discuss in the 8th standard. So the 4th fundamental quantity is electric current. The unit is ampere. It is denoted by the symbol A. And 5th one, temperature. Unit is Kelvin. It is denoted by the symbol capital K. So the ampere and the Kelvin both are denoted by the capital symbol only because both the units are units taken from the name of the scientist. And 6th one, amount of substance. The unit is mole. It is denoted by the symbol MOL. And last one is luminous intensity. Unit is scintilla. It is denoted by the symbol is CD. So students, I hope you understand what and all we discuss in this video. So let us see in the next video. Thank you children.